at insulation, I kind of thought about this as saying, really, is it structural? For the past, been in the construction industry now for 20 years, and I got to say for the first half of my decade of training, I never really thought about insulation. Long or hard, never really thought about it much. And so today this presentation is really for the professionals in the room, just to kind of give a little bit of food for thought, maybe something that kind of sparks some interest. So, you know, does insulation transfer load, right? We have snow, we got wind, all of the gravity loads that are trying to make its way down to the earth. And in the commercial sector, the part 3, we kind of had Z-girts on the outside of things. We've had insulation on flat roofs, put some gravel on there, maybe, you know, the Green Roof Initiative, put some pavers on there. But in the residential sector, the low-rise, the custom homes, I kind of feel that it still feels a little bit new to the industry. I always have somebody coming to me saying, this is a better detail. There's a new way of doing it, something different. So as a structural engineer, I'm starting to listen to things because as engineers, it was more in the mechanical field, and now structural, we're being pulled in to what does this mean for high performance building. So I wanted to throw this up here as engineering because I have a lot of friends say to me, what do you do? Because a lot of people can understand, I think, resonate with what an architect is or what a contractor is, but the engineers, especially in the custom homes, the residential sector, no one really fully understands what I do. So I'm a structural, civil engineering background, and I like to say to people that I apply the art of science and some math, right? We try to be creative, we try to throw some common sense into things, we try to support here, and I want to throw out there that yes, we need to think of the environment, right? We think about how the house interacts with the environment, but I honestly believe that we have to do it for the benefit of the people. And we interchange this word. I want to throw out there, we interchange this word between house and home. I want to throw it out there to everybody that a house, in my opinion, needs to have humans living inside, thriving. And then that's a home, right? So we're working on a house. So let's start on the roof. So when it comes to roof, snow loads, even the green roof, when it comes on the green roof, you know, the loads aren't that heavy. So when it comes to the type of insulation product that's there, it's not that big of a deal. If it's sloped, you know, we have some amazing screws over here from Rothoblast that can either, you know, soft insulation, hard insulation. Do you want to transfer through the insulation? Do you want to just hold it down? You know, City of Toronto's, when it comes to the initiative of the green roofs, we've kind of started to understand that we've actually have to care about the wind uplift, make sure things don't fly off the roof. A new one that the structural engineers are having to deal with is kind of these overhangs, right? We're debating over thermal bridging. We're debating over, do we do sleepers? Do we do outriggers? And we can be very creative, and there's amazing screws out there on the product and different ways that we can actually be creative with these overhangs. I want to share with you guys my struggle, the structural engineer's struggle, okay? I'm not going to bring you down a university course here about structural design. You know, as structural engineers, it all breaks down to this very basic logical function. It's statistical analysis, okay? We actually have a load effect. So how many people have actually heard about factors of safety or limit states design? You know, we had working stress design back in the day. The US still kind of has these two codes, working stress, limit states. Canadians decided to switch over to limit states design. And people say factor of safety. And how many people have said, that thing's over-engineered? I like to joke around and kind of say, well, what's under-engineered? And I like to kind of say, what the really meaning is that it's costing us way too much. You've been a little bit lazy with what you've been designing. The steel price has gone up. It's costing us way too much. So we kind of work through this predictable, what's the load effect, right? Code standards, they tell us how to deal with all that stuff, right? When it comes to limit states design, it's also confidence, right? How well can we predict how steel's going to break versus earth is going to actually fail? But I just want to have a little fun here. Just pure compressive strengths. I just want to throw out here. We're also Canadian. So do you identify what your weight is pounds or kilograms? Do you identify with your height as feet or meters? So I'm having this fun playing around between what is an MPa? We tend to understand strengths of some of our building materials in megapascals. We also kind of think in terms of loads as kPas. PSF, we kind of play around here. So 2 feet of snow, 2 feet, it's around your living room. People, we kind of throw around this idea of 2 kPa or 40 pounds per square feet. You know, even just like parked cars, all those green P parking, it's only around 50 pounds per square feet. A dance floor, throwing around here, 100 pounds per square feet, it's 5 kPa, okay? I've had people say to me, I don't want just a green roof, I want a landscaped roof. I want a foot of soil on top, okay? That's around 6 kPa. All of that, it's like, it adds, it's 6 kPa or around 100 pounds per square feet. It's still peanuts in the MPa strength, and it's actually still under 1 PSI. It's once you start stacking all this stuff up, when it comes to concrete foundation, concrete walls, brick walls, double white brick walls, multiple different floors, all of a sudden, okay, you know what? We're now getting into 17 PSI. And so I want to kind of compare that to compressive strength. When it comes to insulation, rock wool, rigid, it's got a great product out there. I got the question lately, can I put it under foundations? Not yet. Rock wool hasn't gotten there for under foundations yet. They're advertising under slabs. You know, it's a great product, but it's only around 3 PSI in strength. We got the high load, right? 40 PSI, 276 kPa, 5,000 pounds per square feet. You know, it's still under 1 PA, like 0.28 MPa strength. And I've had people say to me, do I actually have to spend that much money? Because engineers can be lazy and just say, put high load underneath there. So the thing I just want you guys to think about is rigid insulation is around as strong as great soil. Okay? It's as strong as your dense silt, compacted gravel, silt clay. But it's not there when it comes to concrete, steel, wood, rammed earth, clay bricks, sound bedrock, okay? So this is supposed to say under foundations. So Joe, like, I still didn't get to update this. So under foundations. So there's some great articles here. I was first introduced to this when it comes to just pure frost protection. Right? In the 70s, there's been articles in the Geotechnical Foundation Manual that look at insulation from frost protection, extending only just 2 inches, R10, 4 feet, 6 feet. And there's a cool little guide actually by the CMHC, First Nations, Rural Ontario, when it comes to how do you extend insulation. So the one thing I wanted to point out there from pure frost protection, there's 3 factors. You need soil that is frost susceptible. We don't want silts and clays, right? Water wants to stay there. You need water standing there, and then you need the temperature reducing it to actually cause the frost. Okay? So now I just wanted to kind of point out to that when it comes to, I'm going to jump ahead here so that I don't take too much time here and how long I'm actually going. So, I just wanted to share some lessons learned. Putting rigid insulation under the foundation wall seems to be a simple little solution, but prepping the subsoil, it can actually be a little complicated. This contractor with shoring had some water issues. You know, thinking about that subgrade is something that we need to think about. And in basements, as Joe said, is more expensive, okay? So in basements, I do recommend geotechnical study to really understand what's going on. And here I'll just throw out there some lesson learned as well on this one site that we had. You know, the contractors that are working it, I blocked out the name, and I blocked out the faces, but they actually had to kind of pull out their backhoe. So they went in there not fully understanding, but we filled with U-fill, prepped the site, put insulation underneath. So there are some pre-made systems out there. I think there's pros and cons between the pre-made systems. I'd kind of say when it comes to raft slabs is that if you don't have a lot of steps in your lay of the land, you don't have steps in the design, it's actually, I changed my tune. At first I was thinking all the loads coming down on the outside, you should have a knee wall there, but it actually distributes the loads really, really well. Okay, so raft slabs are great if you're not doing a basement and your slabs, everything's kind of flat there. When it comes to details, you know, we come up with some details with just guys saying, I want to buy rigid insulation, playing it. And so when it comes to developing these details, we're constantly evolving them, trying to work with it, okay? So as my philosophy is that we're part of the design team, trying to work with, not trying to over-design, over-detail, but work with the contractor and work with the architect as we're developing them. I want to kind of just jump into now wall systems. So structural engineers were introduced to insulation kind of within the insulated concrete forms, the ICFs. We kind of started thinking about them as temporary. It's holding the wet concrete while it cures. It's not permanent. And then SIPs, they were originally at one point designed as being on the outside of the heavy timber frames. And they were wind bearing, not really load bearing. And we didn't fully trust the insulation. We put splines, 2x4s, tube of lumber, sawn lumber, every 4 feet. I actually had the luxury to be City of Toronto's very first alternative solutions submission back in 2007-8, sat with a chief building official because we had an owner that insisted on using a SIP from the States that refused to be CCMC approved, wanted to go through alternative solution submission. The City of Toronto said, I don't even know how to deal with this, Matt. Like, is this setting a precedent? And so, and because they actually had a lawsuit going on in Ontario with steel and rigid insulation glued and bonded together and delaminating. So they were freaking out. This is polyurethane spread in between, and we actually were able to prove that there was never going to be a bond failure. It was actually either failing right through the OSB or the polyurethane. When it comes to all these different other building systems, the question I kind of have is the structural load on the inside, outside, surface cavity, cladding, composite. So where's the primary structural system? We work through that. I want to draw your attention to, we've talked about the building code changed at one point, trying to advocate for continuous insulation on the outside. And when that started happening, any of these I call production home builders, kind of said, I'm already putting a panel on the outside. I have to pay somebody to put another thing on the outside. So right away, they were looking for alternative systems to kind of say, can I only put one system out there? This really started striking a chord with me because these are my social media posts on Instagram. This is in my neighborhood in North Oakville. This is not a full, I'm taking out all the great rooms, punch window openings. They tore this house down. This house collapsed. That's dense glass. It's got around the in-plane shear strength of drywall. And then the pink stuff. And they're not pushing the limits here. Look at this big wall here. A little bit of sheathing, OSB or plywood, can handle that no problem. And so the one thing that I actually wanted to point out there is that the National Building Code put out a guideline trying to change the verbiage around not just shear walls, but thinking of braced panels, braced wall bands. But Ontario chose not to adopt it in 2012. The Canadian Wood Council actually put out their engineering guide, their black book, talking about this terminology. Ontario still has said, I'm turning a blind eye, and it hasn't hit in the residential and the engineering community yet. So when it comes to in-plane shear and the percentage of walls, it's something that needs to be considered. So I'm advocating that structural engineers should be on these projects, especially when you are trying to minimize the amount of walls and lateral walls and have open window and big window concepts, which are amazing. Let's just design them. So, a shout out to kind of the ZIP system. They actually have somebody that decided to, hey, I'm listening to you guys. We're going to combine the insulation and the wood-based product to make sure that it can actually transfer those lateral systems. And it doesn't take much. There's actually a prescriptive way, 4 feet for every 40 feet of house. So what I want to kind of just, what I love about the high performance building industry when I work with everyone here is this kind of buy-in to increased quality. Everyone who decides to work on the team, from the consultants to the contractors to everyone, we agree that we need this increase in quality. And so a shout out to Simple Life Homes when it comes on the left here, and a shout out to the Acura when it comes to the rammed earth, is that my challenge to everybody is, can we look for ways to create the construction site to be more of an assembly site as things are coming together? Can we look for ways to kind of reduce and simplify that our materials and the wall assemblies become a little bit more robust, a little bit more earth-friendly, overall looking for that sustainable longevity? So can we simplify our designs for sustainable longevity? And with that, thank you for listening to your time. I hope I kind of inspired something that was a little bit of interest.